This is question number 1 of Qz7 for chapter 6. Universal Corporation is planning to invest in a security that has several possible rates of return given the probability distribution of the returns in the pop-up window. So just click on the window and we can open this actually in Excel. And that will facilitate our calculation. So now we have the table in Excel. Go back to the setup. What is the expected rate of return on the investment? Also compute the standard deviation of the returns. What do the resulting numbers represent? So I have 3 parts corresponding to the 3 questions being asked here. A, expected rate of return on the investment. So expected rate of return is basically the weighted average of the individual returns of all the assets within the portfolio. And weight is basically the probability of the occurrence of a certain economy state. So to calculate the expected rate of return, we just need to calculate the weighted average. And to calculate the weighted average, we just need to sum up the product of the probability and the return under a given economy state. So here I just the probability, I just calculate the probability, the product of the probability and the return. So just equal the probability and times the return. And that also shows the convenience of using Excel, because now while I calculated the first product, I can just drag the cell to the other economy states, and Excel will automatically calculate the products for me. So now I can calculate the ER or the R for this stock that represents expected rate of return. Now we can basically sum up all these 4 products, and that gives me the expected rate of return. And then for math cells, just go back and check the rounding requirement. This is in percentage term and round to 2 decimal places. So just keep it in percentage and round to 2 decimal places. So that leaves this with 8%. And the standard deviation of the returns can be standard deviation. We know it's also sort of it's actually a square root of a weighted average, but it's a weighted average of the squared deviation. So to calculate the standard deviation, we just need to calculate the weighted average of the squared deviation. To calculate the weighted average of the squared deviation, a square deviation of what? Square deviation of the each individual stock return from the expected rate of return. So that's the deviation, and then we take the square of that, and then we multiply by its corresponding probability. So that's weighted by the probability, and then we sum them up. That becomes the weighted average of the squared deviation. And then finally we take the square root of that, and that's how the standard deviation is calculated. So the probability times squared the deviation. First, calculate the deviation, right? Deviation is return minus the expected return, and then that's the deviation, and then square it, and then we already multiply this by the probability. So just calculate this based on this formula, equals probability times squared by squared deviation, which is return minus this expected return. But in writing this cell value for the expected return, I want to fix this cell value. Why do I want to do that? Because later on, when I drag the cell to the other economy states, I don't want this number to change. Yeah, this is the common number across all the economy states. So that's why I want to fix this cell number. So hence fixing the cell value. So then I can just take the square of that. So this, so far, this is the product of the probability and the square of the deviation of each individual return from the expected rate of return. So then I can drag the cell to the other economy states, and then I can just standard deviation is simply also the sum of it. I can actually even make this simpler to be just drag the cell here to the other column. So this can also automatically calculate this for me. But remember, this is only uh, the weighted average of the squared deviation, but we also need to take the square root of that to calculate the squared to calculate the standard deviation. So standard deviation now becomes 11.22%. So that gives me 11.22%. That's also consistent with this rounding requirement. And part C, what do these resulting numbers represent? Basically, this is asking us our statistic knowledge. So with the expected return, we know the expected return is like the mean of a statistical distribution, and the standard deviation is like the variance or the standard deviation of the distribution. So then how can we understand this uh, basically the shape of the distribution based on these two statistics, like the expected rate of return and the standard deviation? And if you check the book, actually they state this very clearly here on the section, chapter 6, section 6.2, risk defined and measured. It says that we should remember that statisticians tell us that two-thirds of the time an event will fall within one standard deviation of the expected value, assuming the distribution is normally distributed, that is, it is shaped like a bear. So that's the common assumption, normal distribution. And with that assumption, and then the statistics tell us that an event will fall within one standard deviation of the expected value with two-thirds of the probability. So that's how we can interpret the statistics here. And with that knowledge, we just check which of these four choices match that interpretation. Universal could expect a return of 8% with a 67% possibility that this return would vary up or down by 11.22%. I believe this is exactly what the this paragraph simply tells us, simply means, right? Because this 8% is like the mean of the distribution, and 11.22% is like the standard deviation of the distribution. So this basically says that the the return will be within the one standard deviation up or down the expected rate of return with uh, two-thirds of the time. Um, so that's exactly what this sentence tells us. Could expect a return of 8% with 67% possibility that this return would vary up or down by 11.22%. 11.22% is simply the standard deviation. So the return will be vary up or down by this margin with 60% of the chance. So that's exactly what this means. And all other numbers just a mismatch of the return and the standard deviation. So, and also sometimes the probability of the occurrence of this is wrong. It's not 25%, it's two-thirds. Two-thirds is almost 67%. So now I can check my answer. The input is correct.